All right, now we're going to move into questions 2 and 3. And question 2 actually starts with 5.03 times 10 to the 23rd molecules of water. And we're trying to figure out how many grams of methane, CH4, would produce that many molecules of water. So if we look at this combustion reaction up here, we have methane plus oxygen yields CO2 plus water. And we can look at these coefficients to determine how many moles we have of each of the following. So methane has a coefficient of 1, so there's only 1 mole in this equation. Oxygen has a coefficient of 2, so 2 moles. CO2 has a coefficient of 1 mole, and water has a coefficient of 2 moles. Now we're going to move into what our given values were and how many moles there are going to be in that initial given value. So we had 5.03 times 10 to the 23rd molecules. I'm going to abbreviate it, MOLEC, of H2O. And prior, we learned that Avogadro, it's a very old dude, came up with this idea of the mole, so that 1 mole of a substance, in this case water, is equivalent to 6.02 times 10 to the 23rd atoms or molecules. In this case, it's water. So when we divide 5.03 times 10 to the 23rd and by this number, we should get our moles of water. Parentheses are going to be really important in this one. So remember, we can times this by 1, should just be the same thing. And then we're going to divide by 6.02 times 10 to the 23rd. So remember, that's Avogadro's number. We're going to get 0.835 moles of water. All right, it's hard to step down. Next, we're going to look at the molar ratio between methane and water. So going back up here, we find that methane had a coefficient of 1 and water had a coefficient of 2. So for every 1 methane, there's going to be 2 water molecules or moles. All right, so given that we had 5.03 times 10 to the 23 molecules of water, how many moles of methane would be needed to complete the reaction? So we already found that this amount, or this many molecules of water yielded 0.835 moles of water, and I kept that number in my calculator. Now we're going to use our molar ratio. We just found some up here, right? So we had 1 mole of CH4, for every 2 moles of water. Again, you'll notice that mole of water here, and it ends up at the bottom of this ratio. So when we multiply this value by 1, we should get the same thing, right? So you can skip that stuff in the calculator. Then divide by 2. We find that for 0.835 moles of water, there are 0.42 moles of CH4. All right, last step. I have that long number in my calculator still. So given this value, so this many molecules of water, how many grams of CH4 would be needed? So we found out the moles of water. Then using the moles in the molar ratio, we found out the moles of CH4, so that methane. Now we can use the moles of methane. And we are going to use the molar mass this time. So remember, mole of CH4 goes down here. We've already used a mole ratio, so we're going to use a molar mass. So remember, molar mass, there's only 1 mole. And then we look at our periodic table. This time we have carbon, which is 12, and we have 4 hydrogens, which are 1 times 4. So we end up with a molar mass of 16 grams per 1 mole. So the 16 grams of methane goes up top, and this equals, so this really long number here, times 16. So we get 6.68 grams of CH4. Sorry, it's hard to see there. Notice I got my units. All right, so now we're using the balanced chemical equation given, and we're going to use the fences that are provided. This kind of gives you a hint to how many steps there are. So for A of 3, so we're looking at silver nitrate plus copper. Hey, that's from our lab. Yields copper nitrate plus 2 silver. And we want to find out how many moles are in 3.45 grams of silver nitrate. Oh man, we're going to have to come up with a molar mass of silver nitrate. So this time I'm going to do it over here in the corner. Hopefully you can see that. So silver has a molar mass of 107.87. We've got nitrogen, which has a mass of 14, oxygen, which has a mass of 16, and there are 3 of them. So this totals out to be 48. So we get 48 plus 14 plus 107.87 equals 169.87 grams per 1 mole. All right, so here, remember this unit needs to go on the bottom. So we've got the grams of AgNO3. It doesn't make sense to put the same thing down here. We're going to put this molar mass. From there, we can put that 1 mole on top, because we know that 1 mole of silver nitrate weighs 169.87 grams. So when we take 3.45 and we multiply it by 1, we get 3.45. Divide by 169.87, we end up with 0.02 moles of silver nitrate. So I'm going to keep that number in my calculator. Second steps, how many grams of carbon does it take to produce 1.20 moles of silver? Man, this is kind of a confusing question, but we're given a number, so that's what we're going to start with. So we have 1.20 moles of silver. So this unit needs to go on the bottom, moles of Ag. We could put a molar mass up there, but we're not trying to find grams of silver. We're trying to find grams of Cu. So we really need to find moles of Cu. So we can put moles of Cu up here. Now we need to look at their coefficients in the balanced chemical equation. So there's 1 mole of Cu for every 2 moles of copper. All right. So the question asks for grams of copper. We are at moles of copper based on what we have down here. So this unit, again, is going to travel down here. And this time we're going to use a molar mass so we can get grams of copper. So moles of Cu, there would be 1, and according to our periodic table, for every 1 mole of copper, there are 63.55 grams. So we're going to plug this into the calculator now, erasing that old value. Sorry, we had to keep it. We didn't really. 1.2 times 1 times 63.5, don't forget your decimal, gives me 76.26. Now I'm going to divide that by the bottom, which is in parentheses, 2 times 1, which is really just divided by 2. So I get 38.13 grams of copper. So remember this, moles of Cu canceled, moles of Cu, moles of silver, moles of silver. All right, last one. How many molecules of copper are going to react with 3.64 grams of silver nitrate? Ooh, so this is our given, so we're going to start here. 3.64 grams. We can do kind of similar to here because it's almost the same. It's just a little bit off, but we're going to put that 1 mole of silver nitrate. Sorry guys, I forgot the silver nitrate. And I forgot the L. Jeez. So 1 mole of silver nitrate, we already calculated the molar mass, 169.87 grams of silver nitrate. Running out of room. So now that we have grams, those will cancel. This unit, the moles of silver nitrate, will go down here. We need to look at our balanced chemical equation. So there were 2 moles of silver nitrate. We are trying to find molecules of copper, so we're going to look for that. So copper was 1 mole of copper. All right, and now we're at moles of copper because our moles of silver nitrate have canceled, our grams of silver nitrate have canceled. We want to get to molecules of copper. So I know, based on Avogadro's rule, that 1 mole of copper, these are opposing, remember, so they can cancel out, is equal to 6.02 times 10 to the 23rd molecules of copper. All right, let's do the math. 3.64 times 1 times 1 times, in parentheses, 6.02 times 10 to the 23rd equals a very large number. We still need to divide by our molar mass though. So we're going to put this in parentheses, 169.87 times 2 times 1, finish that parentheses, and we find that our answer is 6.4, I'm going to round to 5, molecules of copper. So here, the grams of silver nitrate cancel, moles of silver nitrate cancel, moles of copper cancel, and we're left with molecules of copper. All right, hopefully this helped. Have a good night.